Let's do this problem right here. The question is asking, consider the following system of linear equations, and they have given a matrix right here. And first question is asking, find x and y such that the system has no solution. Then second one is infinitely many solution and unique solution. So in this case, if you look at this matrix, we don't like, since we don't have 0 0 right here, we don't have control of this over these questions. Over these equations like x minus 1, y minus 6, we don't have control unless this one is 0. So to find the solution, to find these numbers, I had to first bring this one into 0, and to do that I had to do the coefficient. So let's see, not coefficient, Gauss elimination. So I'm bringing everything below the diagonal 0. So in this case, let's see what I can do. So first of all, I'm bringing the matrix right here. So 1 3 0 0 1 2. Then here we have, okay, 0 1 2. Then here we have 0 2 x minus 1. On the other side we have 5 1 y minus 6. So to make this one 0, I can multiply the second equation by -2 and add it to the third one. So if I do that, I will get 1 3 0. This is going to be 5, and here we will get 0 1 2. Here it's going to be 1, and to eliminate this one, I multiply the second equation by -2. So it's going to be -2 r2 plus r3. So if I do that one, this one will become 0, and this one will become -2 times 2 is going to be -4. So x minus 1 minus 4 is going to be x minus 5. The other side is going to be -2 times 1 is going to be -2, y minus 6 minus 2 is going to be y minus 8. Now we have everything 0 0, and we have these two equations right here. So we have now control over this. So we can now determine what number will make these kind of situations. So first let's go to A. So A asking, find all x and y such that system has no solution. So in order to have a system with no solution, we have to have a set of row that has to be 0 0 0, and this one, in this column, it has to have a number. So 0 0 0, a number. What numbers will make that kind of situation? In this case, for this one, if I put x is equal to 5, this will make this one 0. So we can say x is equal to 5, but to bring a number in this side, because it has a 0 0 0, a number. So to bring a number in this side, I had to have any number except 8. So y shouldn't be equal to 8, because if it's equal to 8, then this will become 0. So we shouldn't have a 0, then that will make the situation that system has no solution. So y is not equal to 8. So that's the answer for the first question. And the second question is asking, find all x and y such that the system has infinitely many solutions. To have a system with infinitely many solutions, we have to have a row with 0 in all of this. So in this case, to have that kind of this situation, what we have to do is we have to have x is equal to 5, because if you have x is equal to 5, this will become 5 minus 5 0, and y should be equal to 8. Then this will become 8 minus 8 0. So that's what we have to have. So therefore, the answer for this one is x is equal to 5, y is equal to 8. And then the next question is asking, find all x and y such that system has a unique solution. To have a unique solution, we shouldn't have a row with a 0. We should have a number. So that will make the unique solution. It doesn't matter what happened right in this side, but in this side, if we don't have a number, the system doesn't have a unique solution. So therefore, this one has to have a number, and this one can be any number. It can be 0 to 0, doesn't make anything. Therefore, the answer for this one is x shouldn't be equal to 5, because if x is equal to 5, this one will become an infinitely many solution or non solution. So x shouldn't be equal to 5. Y can be any real number. So y can be any real number. So that's the answer for the third question, and that's how it's done. I hope you guys understood this concept. See you next time.